Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session, we are going to discuss a numerical problem on the topic motion in straight line. This is the numerical on turning a corner, a motorist rushing at 20 meters per second finds a child on the road 50 meters ahead. He instantly stops the engine and applies brakes. So as to stop the car within 10 meters of the child, we have to calculate retardation and time required to stop the car. Okay, so here a motorist initially rushing at 20 meters per second. It will be the initial velocity. When he finds a child 50 meters ahead, he instantly stops the engine and applies the brake. So he has to stop the car within 10 meters of the child. Okay, before 10 meters, he has to stop the car. Okay, initially he is running or rushing at 20 meters per second. That will be the initial velocity. He finds the child on the road 50 meters ahead. He instantly stops the engine and applies brakes. So finally the car will be stopped. It has to be stopped 10 meters ahead of the child. Okay, so we have to calculate a retardation and time required to stop the car in this numerical. Okay, so we'll go to the numerical. First, I'm going to write the given data. Okay, the given data. Here, the car is initially moving at 20 meters per second. So it will be the initial velocity which is equal 20 meters per second. And then instantly when he finds a child, he instantly stops the engine and applies the brake. So finally the car will be stopped. Okay, so the final velocity of the vehicle, that will be 0 meters per second because the car is stopped. Okay, finally the car is going to be stopped. Okay, that's why the final velocity equal 0 here. Okay, here guys, initially the car is here. Okay, that means at 20 meters per second, 50 meter ahead of the child. Okay, when you see a child 50 meter ahead, he stops the engine initially, instantly, and applies the brakes. So he has to stop the car at least, that means 10 meter before the child. So the distance traveled by the car will be from here to here. Okay, that means from x equal 0 to x equal 40 meters. That is 10 meter before the child. Okay, so the distance traveled by the car, that will be from here to here. That means 40 meters. Okay, so the distance traveled by the car, which is yes, that equal to that 50 minus 10, that equal to 40 meters. Okay, so these are all the given data. What are all the things here we are going to find? Okay, first one, the retardation. We have to find the retardation. it means that acceleration in the opposite direction, that is the minus a, or the a we will get in negative. Second one, we have to calculate the time required to stop the car. Okay, time required to stop the car. Okay, then the solution of the numerical. First, I'm going to write the kinematic equations of motion for our reference here. Okay, the kinematic equations. First equation, we know that V equal U plus AT. S equal UT plus of AT square. V square equal U square plus 2AS. Okay. Here U is the initial velocity, V is the final velocity, A is the acceleration, T is time, and S is the distance. Okay. So here for the solution, we have to find the acceleration by using the data whatever given here. We know initial velocity, final velocity, and distance. And we have to calculate A and T. Okay, A and T we have to calculate. First, to find acceleration, we can use the third equation, because here the final velocity V is the known value, U, that is also the known value, acceleration only we are going to find, and distance, yes, that is also the known value. So except the acceleration, all the values we know here. Okay, so we can use this relation first to calculate the retardation. So I'm going to write this equation, V square equal U square plus 2AS. Here A only we are going to find. So, and then first of all, the final velocity, that is 0. Okay, because the car is finally stopped. So 0 equal U square plus 2AS. Here A, that is the acceleration only we are going to find. So we can rearrange this equation as 2AS. Okay, we can rearrange this equation as 2AS, that equal to minus U square. And then acceleration, A equal minus U square divided by 2S. Now substitute the values. Okay, now substitute the values. That initial velocity, that is 20, so minus 20 square divided by the S, that is 40 meters given here, so 2 into 40. Okay, so we can write this as 20 square, that will be 400, so minus 400 divided by 2 into 40. Okay, that is 80. We can cancel this 0. Okay, we can cancel this 0. And if you divide this 8 with 40, we will get 5. So the final answer, we will get minus 5 meter per second square. So the acceleration equal minus 5 meter per second square. Okay. Here, the negative symbol denotes the acceleration acts in opposite direction. Okay, the acceleration acts in opposite direction. Okay, then we have to find the second one, time required to stop the car. Okay, the second one, we are going to find the time required to stop the car. What is the time required? Here, guys, among these three equations, we know velocity, that is the final velocity, initial velocity, and the acceleration, that also we found here. So we have to find only the time. So we can use this relation. Okay, it means that like v equal, so I'm going to use the first equation, that is v equal u plus at, and we are going to find that time only here. Here also we know the final velocity, that equal to 0. So if you substitute 0 for final velocity, u plus at. Okay, and we are going to find the time. So if you rearrange this equation, at, that equal to minus u, and t equal minus u divided by a. Now substitute the values. The final velocity is 20 meters per second. So substitute it here. So minus 20 divided by the acceleration. We found minus 5. Okay, if you substitute, this minus and minus will cancel each other. So we will get, if you cancel this, 4. So the time equal to 4 seconds. Okay. So this is the time required to stop the car within 10 meters before the child. Okay. So finally, the results. First one, acceleration, that equal minus 5 meter per second square. Second one, the time equal 4 seconds. Okay. So I just recall once again, guys. Here, on turning a corner, a motorist rushing at 20 meters per second finds a child on the road 50 meters ahead. Okay. He instantly stops the engine and applies the brake so as to stop the car within 10 meters. Okay, within 10 meters of the child. So we have to calculate retardation and time required to stop the car. Okay, first the given data, the initial velocity 20 meters per second. Here, finally the car is stopped. That's why the final velocity is 0. And initially the car is here when he saw the child, and the car has to be stopped 10 meters before the child. So the distance traveled by the car will be 50 minus 10. That will be 40 meters. We have to find retardation and time required to stop the car. Okay. So here for our reference, I had written the kinematic equations. Among these three equations, first I used the third equation, since except the acceleration, what we have to calculate, all other data are known value. Okay. So v square equal u square plus 2as. Substitute the value of v. final velocity 0, and rearrange the equation, substitute the values of u and s, simplify, we will get the value of acceleration. Here, the negative symbol denotes that the acceleration acts in opposite direction. That is called retardation. Okay, it means the car is moving towards right side. This acceleration will act in towards left side. Okay, that is opposite direction of motion of the car. Okay, second, we have to calculate the time required to stop the car. So for this, I'm going to take the first equation of motion, that is v equal u plus at. Here, the final velocity, as usual, the car is stopped here, so that will become 0, that equal u plus at. So rearrange the equation, we can write at equal minus u, and then t equal minus u by a, then substitute the values of u and a. We will get, and when simplify, we will get the value for time. Okay, then finally the results are noted. Okay, so many solved numericals on motion in straight line. Okay, in this topic we are going to discuss in the further videos. Okay, so to watch all the videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay, thank you guys. Thanks for watching.